In this video, I'd like to talk about how to add polynomials. And we have this example problem, and the basic strategy when adding polynomials or subtracting is that we basically just need to combine like terms. So remember, a like term, like if I had 4a cubed plus 7a cubed, they both have a cubed in it. So I have 4 of these a cubes, and then I'm adding 7 more, and so in total I have 11 a cubes. But if I have something like 2x plus 1, these are not like terms. We can't add these together because this doesn't have an x in it and this does. And since we don't know what x is, there's just no way to combine these. Now, if we know what x is, like if x is 2, then this would just be 4 plus 1, which is 5. But x at this point could be anything. So these cannot be combined. But if this was 1x, then this could be combined because now you have 3 x's. So this entire video is basically focused on just combining like terms with these polynomials that we're adding together. So what I like to do is generally either an underlining method or using letters just to keep everything organized. So I'll use underlines first. So the cube terms, I'm going to use 1 underline. The square terms get 2. And we just have 1 term with an a to the first power. So I'll put 3 for that one. Now you could also use letters, like a for the a cubes, b for the a squareds, and c for the next one. And frankly, the more terms we're going to be adding, the better that using letters will be. The underlining method can get kind of messy. So one thing to note is first, we're adding this polynomial that's in parentheses. And since we're adding, we can effectively just drop the parentheses. Because if you want to think about it, it's like we have an invisible 1 here that multiplies or distributes into all 3 of those terms. And effectively, it won't change the sign. So we're going to rewrite this. Let me change colors. We have minus 5a cubed minus 2a squared. And then we're just dropping the parentheses because we have a plus sign in front. Now, if it was subtraction, we'd have to be more careful because then we'd have minus that entire polynomial, and we would have to distribute this negative because effectively this is minus 1 times everything. So we would distribute this negative 1, and what would happen is all the signs would flip. So that's what we would do if we were subtracting, but since we're adding, we can just drop the parentheses. And then again, we're going to combine these like terms. So we gave these 1 underline, so we have minus 5 of these a cubes plus 6 of these a cubes. So we're just looking at the coefficients, the minus 5 and plus 6, that would just be 1 a cubed. And then next we have the a squared terms. I'll use 2 underlines for that. And we have minus 2 here and plus 9 here, and so we'd have 7 a squareds left. And lastly, we have this 8a term, but since there's nothing to combine it with, we'll just write plus 8a at the end. So this would be our final answer. And of course, you don't have to keep the 1 in front of the a cubed, but you can leave it if you want. And now that we have the general strategy in mind, let's just go through several more example problems. So I'm first going to rewrite this without the parentheses. And since we're adding, we can just ignore it. So we have plus 8b, and then we'll say minus 4b cubed because we're adding a negative, which is the same as subtracting. And we have plus 5b squared, and then we have minus 8b. And from here, let's use the lettering method. So for b squared, I'll give that a. So that's b squared, that's a b squared. B cubed, we can give that a b. There is no other one. And then the b terms, we will call c. So let's combine the a's first. So you have minus 4b squared plus 5b squared. Well, minus 4 plus 5, that's just 1b squared. And then we'll combine the b terms, but there's only one of them. So we're at minus 4b cubed, and then we'll combine the c terms. We have 8b minus 8b, so that's just 0. And we want to write it in standard form. So what we have to do is put the highest power of b first. So we have minus 4b cubed. Let me rewrite that. And then plus b squared. So essentially the signs would carry on with these. They just switch places. So this right here would be our final answer. And let's move on to the next one. So we're adding again. Now, let me just show you an example if we were subtracting. So I'm going to change this sign to a subtraction problem. And when I rewrite this, so here's where you'd have to be careful if you are subtracting polynomials, because we're subtracting this whole thing. So really, this negative gets distributed to each of these terms. And so whatever their sign is before, now it will be the opposite of that. So we have minus d cubed, then we have minus 6d, and minus 9. So effectively, every one of these became negative because they were positive originally. Now we can combine like terms. So let's do, we'll call the d squared ones, we'll call that a, and it doesn't look like we have any more. And then we'll call the d terms, we can call that b. So there's another d term there. And we have a constant term, we'll call that c. Here's another one. And then we've got this cubic term, which I'll give with d. Now, I'll write the cubic term first because we want it in standard form, and we only have one of them. So we have minus d cubed. And then let's do the a's next because we want the squares. So we have d squared, and that's it. So we'll just write plus d squared. Now we have the d terms, and we have plus 60 and minus 60. So those are going to cancel. And then we have the constant terms. We have plus 9 and minus 9. So those are going to cancel as well. And so this would be our final answer written in standard form.